In this video, we'll be looking at Chapter 14, Section H, on where functions meet. Let's consider two functions. One is a quadratic function, or a parabola, that has this nice U-shape, and one is the function of a straight line. Notice I have three different drawings here, each of which represents different ways in which these functions can interact. In the first case, we see that the line can intersect the parabola in two places. In the second case, we see that the line barely touches the parabola and they intersect or touch at only one place. And in the third drawing, we see that there is no intersection at all. There are no points in common. Each of these scenarios has a name. The first is cutting, the second is touching, and the third is missing. And again, in the first case, we have 2 points of intersection. In the second, we have 1 point. And in the third, we have no points of intersection. Now, for the cases where we have intersections, we can find the coordinates of the points of intersection by solving these two functions or equations simultaneously. And hopefully you've seen how to do this before, solving equations, at least two equations simultaneously. Some of you probably have seen how to solve three equations simultaneously. And there are really three different ways that we can solve systems of equations simultaneously, but we're going to focus on the algebraic or the substitution method, which I'll show you in a few examples next. You can, however, graph to find the intersections, and if you know what you're doing with your graphing calculator, it might even tell you the points of intersection. And you can also combine the equations, or essentially add them, and that's called a linear combination. And we're not going to look at that yet. We're really going to focus in on the substitution method. So let's take a look at a few examples. So let's take a look at our first example problem. We're asked to find the coordinates of the points of intersection of the graphs with the following equations. We have y equals x squared minus x plus 3, and we have y equals 2x plus 7. Now, we're going to find the points of intersection when these two equations are equal. So we're really going to set these two equations equal to each other and simplify. And that's because we know that y equals y in this case, and in order for the 2 points to be on both graphs simultaneously, the x values have to be the same as well for those solutions. So what we're going to do first is set the two equations in terms of x equal to each other, and then we can simplify. So I'm going to bring the terms on the right hand side over to the left hand side, so that we get x squared minus x plus 3 minus 2x minus 7 equals 0. And we can clean up this a little bit and add like terms, so that we get x squared minus 3x minus 4 equals 0. And we can do a little bit of factoring here to solve for x. We have x plus 1 times x minus 4 equals 0, and therefore x equals -1 or 4. Now, we are not done here. This is not your solution. Remember, we're trying to find the coordinates of the points. That means I need both x and y coordinates. I have come up with 2 x coordinates. And so now I need to plug these in back into the original equations, and it doesn't actually matter which equation I'm going to use, so let's use the simpler one to find my y coordinates. So let's plug -1 in for x into the second equation. So we get y equals 2 times -1 plus 7. Well, we can see that that equals 5. And we can also plug in 4 into that equation. So we have 2 times 4 plus 7, so 8 plus 7 is 15. And it's important to then write the solution, which are my two coordinates. I have -1, 5, those coordinates go together, and I have 4, 15. And these are my 2 points, and you can check by plugging these both in to the original equations, and they should both work out. Plug in those x's and you should into both equations, and you should get the y's. So let's take a look at another example. Again, we're asked to find the coordinates of the points of intersection of the graphs with the equations. In this case, we have y equals -x squared minus 2x plus 5, and we have y equals x squared plus 7. So let's use the same methods as in the previous example. We'll set these two equations equal to each other. And I will, in this case, I'm going to bring the terms on the left-hand side over onto the right-hand side, just because I like working with positive signs instead of negative signs. So we'll get 0 equals x squared plus 7 plus x squared plus 2x minus 5. And if we simplify, we get 0 equals 2x squared plus 2x plus 2. Notice that we have a common factor in all three terms, which is a 2, so we can take that out. So I have 2 times x squared plus x plus 1. So if I try to factor this, I might have a hard time. I'm not sure that I can find a factored form of this that fits this nicely. So if I'm unsure of the answer, if I don't think it's a really nice answer that's going to get me integers per se, let's switch to the quadratic formula. And remember the quadratic formula, if we solve for x, for a quadratic function, equals minus b plus or minus square root of b squared minus 4ac all over 2a. Where the first term, where a is the coefficient of the squared term, so a would be here, b is the coefficient of the x term, and c is the last number in the quadratic. So if I plug all these in, I get a quadratic formula that looks like this. And let's take a look at the radical sign here, at the square root sign. Notice, if I simplify this a little bit, just the radical sign, I get 1 minus 4. That's the square root of -3. Well, can't take the square root of -3, not in the real world anyways, not with real numbers. So that means there is no solution here. I can't find an x that satisfies this equation. And if you don't believe me, you can always graph, and graphing would work. Graphing would show you that these two equations, right, our two original equations, which are both parabolas, do not touch. Okay, they do not touch. So this is an example of two equations that are missing. There's no points of intersection, and that's fine. It's completely possible and plausible. So don't be surprised when you get no solution for an answer.